thank you everybody for joining this webinar about Docker-based pipelines. So my name is Guy Salton. I'm a solution architect here in Codefresh. So I help with technical project, POCs, demonstrations, webinars, workshops, stuff like that. And if you have any further questions after the webinar, feel free to drop me an email. You see my email there on the bottom of the screen. And today, let's quickly go over the agenda. We're going to talk about an alternative way of using Docker containers, not as deployment artifacts, but as build tooling. So we'll see how to use containers in continuous integration workflows, how to Dockerize your tools to use them inside these workflows. We will see some classic issues of using multiple versions of the same tool in the same pipeline. Like, let's say I want to use Python 2.7, but also in another step I have like a third-party tool that needs to use Python 3. So we'll see how using containers can help me with that. And we also have a GitHub repository that you can see here on the screen, and with all the examples, all the demos that we're going to show in this webinar. So you can feel free to go and fork this repo and use these examples. Okay, so let's start with the theory of Docker-based pipelines. So as I mentioned at the beginning, when people say that they're using Docker in production, that they're using containers in production, 90% of the cases, they mean that they use Docker as deployment packages, which means that the final package gets in a Docker image, and this is what is being deployed. In the webinar today, we're not going to focus on that. We're going to focus on the bottom part of using Docker for build tooling, which is not what most people think. So just to start, let's go over the basics of a software lifecycle, to go over CI/CD processes for those who might not be familiar with them. So we have the continuous integration part, which is the packaging of your application, compiling your source code, running tests, having code reviews. And when we finish, we pass into the continuous delivery or continuous deployment part, which is when the application is being deployed. So that's the CI and that's the CD. Now, if you look at the history, what we call the dark ages, before containers appeared, the situation was very difficult both for developers and for operators, but especially for operators. If you were an operator, an ops guy in a big organization where different tools and programming languages are being used, you have to know everything. You have to know how Java applications are deployed, how Node applications are deployed, how Python applications are deployed, and the same was true for developers. So when containers appeared, and again, this is the main use of containers, when we package everything in a Docker image. So using containers as a build, as a deployment artifact, make the job of the operators much more easy, because they don't need to know how Java is being deployed and how Node is being deployed. They just need to know Docker. So they have a common language between them, and they just need to know how to deploy Docker images. They don't really care about what programming languages are inside the Docker image. They just need to know how to deploy the image. So this using Docker as deployment artifacts makes the job of the operators much easier. But now in today's webinar, we're going to focus on Dockerizing a different part of the software lifecycle, which is the actual continuous integration flow. So this way we will see the full picture of using Docker in the pipelines themselves. So use Docker everywhere, and this makes everybody happy, both the developers and the operators. And so again, this is the part that we will focus on. This is what the talk is about, how to use Docker in CI/CD pipelines and make sure that all tools that take part in the pipeline are packaged in Docker containers. We're going to see some advantages of why this is important and how we can help developers and operators. So again, to go have an overview of the past and how traditional VM-based CI and CD platforms used to work. So if you look at the top of the screen, this is how it used to work. So to run your CI and CD pipelines, you usually had a virtual machine, which acted as your build node, and you had to make sure that you install all of the tools and all of the programming languages that all of the teams in your organization needs on this build node. So for example, here I have Java 6, I have Node 9, I have Go, Python 2, all of these tools needs to be pre-installed. And then each developer brings his pipeline, and the pipeline simply runs the workflow and uses all of these tools. If you look at the bottom part, this is the new approach. And the new approach says that nothing is installed beforehand. Only Docker is pre-installed on the node, and each pipeline brings only the specific tools with the specific version that it needs. So again, using Docker as deployment artifact is not the main focus of this talk, but however, it's also a very important topic, and we fully support it here in Codefresh with different methodologies of deployment, like canary deployments, blue-green deployment, with or without Istio, deployment to Kubernetes. So you can check out different blogs and webinars that we created that focus on Docker as deployment artifact. But going back to our focus of Docker in CI and CD, let's see some of the benefits. So imagine a big organization that has different tools, that develops different programs, and it needs to have what we call a build farm. So many build nodes, usually created as virtual machines. And then imagine the operator in such an organization. He has to maintain all of these build nodes. And because sometimes different teams use different tools and sometimes different versions of the same tool, like let's say I have one team that needs Java 5 to build their legacy application, and I have another team that needs Java 9. So for the operator in this case, he has to label these nodes and say, okay, I have one node that has Java 5 and has Node 8, and another node that I would give a different label to, and this one has Java 10 and Go and Python 2. And then he has to maintain all these different build nodes. He has to upgrade versions whenever new teams needs them. He has to install new tools on these build nodes. But also for the developers, this is very difficult because they need to know in advance exactly which node to choose to run their pipeline, because their pipeline won't necessarily work on every build node, only on the specific node that has the exact tools that their pipeline needs with the exact versions. So build farm after Docker, imagine all these nodes that we saw earlier. This time, we don't need to label them. They all will look exactly the same because the only thing that is installed on the node is Docker. So this makes it much easier to manage. All the nodes are identical. So both for the operator, it doesn't have to maintain different types of nodes and label them with different labels. But also for the developer, it doesn't care which node to choose to run his pipeline on, because his pipeline will work exactly the same on each of these nodes because they are identical. And if we go even deeper to understand how the flow will work, so Docker is pre-installed on the node, and again, all of the nodes are the same. And every pipeline will simply bring its own tools that are packed inside a Docker image. The pipeline will run, it will use the Docker image as an environment to run all of the necessary tools. And after the pipeline is completed, the Docker images and containers are all discarded, and the machine reverts back to its original state. So no change was actually made to the machine, and it always goes back automatically to its original state. And the developers, again, don't have to care about which node to use. And these days, Docker images are everywhere. Everybody knows these days how to build a Docker image and how to run a Docker image. So you can reuse the same images in multiple pipelines and in multiple steps in the same pipeline. You can share these images with your teammates, so there's no need to reinvent the wheel. Let's say now you want to use Terraform in your pipeline and to create some environment, or you want to use AWS CLI. You don't even have to go and create your own Docker image, because most of these popular tools already have a Docker image, a public Docker image in Docker Hub, with the CLI of these tools, so you can just use these existing images. And also for private organization that they want to manage their own images and don't want to use public images, or they want to maintain their own private images, they can have a private Docker registry that will be used only within the organization. Now let's go a little bit deeper and see how this will actually be implemented inside of a pipeline. So in Codefresh, and again, this is the new concept that we're talking about, every step in the pipeline will run in the context of its own Docker image. So let's think of a classic pipeline where in the first step, I would like to, I have a Node.js application. I would like to run npm install to download all the Node modules, then maybe run a test. So for this step, I will use the official Docker image of Node with the version that I want, version 9 in this example. Then on the second step, I would like to collect the test results, the test artifacts, and maybe store them in my S3 bucket in AWS. So for this, I will use the AWS CLI Docker image. And finally, I would like to push my Helm chart to a Helm repository. And for that, I can use, here specifically, it's a Docker image that we created in Codefresh called CF Helm. But it's basically a Docker image that has the Helm CLI installed. And now the pipelines are all created using a declarative YAML, and we'll see some examples later on. So a little bit about Codefresh. Codefresh is the first CI/CD platform that was built for Kubernetes. Codefresh supports and actually was built with this concept in mind of container-based pipeline. Each step runs in the context of a Docker image. It has native support for Kubernetes and Helm deployments. This is what it was created for. And it includes a built-in Docker registry and a Helm repository for every account. So you can all go and it's a SaaS platform, so you can sign up for free and check it out. Today, we're not going to focus on deployment to Kubernetes, more on containerizing your CI/CD pipelines. So let's start with our first demo and see how we use both Python and Node in our pipeline without installing anything on the build node itself except for Docker. So in this case, I have this example here, and this is Codefresh. This is the platform, and here you see a build execution, and we can have a look at my actual pipeline. And I see that the pipeline is created using this declarative YAML, exactly with the concept that we talked about. So in the first step, I would like to package my Node.js application. For this step, I will use the official Docker image of Node with version 11.1. I can run then any commands that will run in the context of this Docker image. So I can run node -- version and npm install to download my Node modules. And then I can have another step for packaging my Python application. This time it will use a Docker image that has my desired version of Python running on it. It will point to the specific path in my Git repository that has my Python application, and then run any commands to package my Python application. And if we look at the build itself, we can see the logs of each of these steps. So we can see that my Node version is 11.1. This is the version that was installed on the Node. And same thing for Python. So it's using the version that I needed. So again, no need to install neither Node or Python beforehand on any build node. We don't have to maintain any versions. We just bring a Docker image for each of the steps, specifically with the tools that we want to use in this step. And again, you can see the example of this YAML file and these applications here in GitHub. Now let's talk about some problems and issues with traditional virtual machine-based platforms, CI/CD platforms. So imagine you work in an organization and suddenly you want to use AWS CLI as part of your pipeline, because like we can refer to the example that we saw earlier. Let's say I want to save some artifacts and push them to my S3 bucket. But if I'm using a VM-based platform, I need to make sure that AWS CLI is pre-installed on my build node. So that means I have to talk to the operator in my organization and open a ticket. Then my operator has to go and see how AWS CLI is installed, and then needs to go and install it on the build node and then update me. And this can take maybe a few days, maybe a week. Same thing for any kind of tool like gCloud or Terraform. I have to open a ticket, the operator has to look into it and see how it's installed, then install it, then update me. Then comes classical questions of users that use a traditional VM-based CI/CD platform, and it's a question of what tools do you support? Do you support my favorite version of Node, of Java, or of Go? Do you support tools like Maven, or Yarn, or Gulp, or Gradle? Can I run Ansible? So all of these questions are now obsolete because we are using Docker. And this is what you see here on the screen is a real example, a real screenshot of a traditional VM-based platform. And you see real tickets of users. They say, I want to add Python 3.7, for example, or I want to add support for this version of Scala or SPT. And on the right-hand side, you see upgrades of the platform. So what kind of upgrades? Like, for example, adding a new version of Chrome driver, upgrading Ansible to a different version. So all of these is now obsolete because you are using Docker. And let's see another example in our second demo. So before we saw a pipeline that used Node and Python. Now let's add a Go application and also usage of AWS CLI. And we will see that we don't need to install anything else. We don't need to talk to an operator to add support for something. We simply go and bring the image with the tool that we want. So we can look at this pipeline and let's look at the YAML file for this pipeline. So I see that on the first step, I'm packaging my Node application. This is the step that was here previously, and we saw it already. Then packaging my Python application. And now let's say in the next step, I want to package a Go application. No problem, I just add another step. I provide a Docker image that has Go installed on with the version that I want. And then again, I can run any commands in the context of this Docker image. So run Go version, for example, to see the version of my Go application and of Go that is installed on this Docker image. Same thing for using AWS CLI. So here I'm adding another step, and this time I want to use AWS CLI. So I'm providing a Docker image that has the AWS CLI installed on. It's the official Docker image of Mesosphere. And then I can run, again, any commands. And this is true for any tool. Like you can see here an example of using Terraform. You don't need to install Terraform. You don't need to go and ask your operator to add Terraform to the build node. You simply add another step with the Docker image that has Terraform running on it. And we can see the logs for each of these steps. So I see that here it's using Go version 1.71. This is what I wanted. And communication with AWS CLI. By the way, I see that on this image, it has AWS CLI installed on, but it also has Python 2.7, while in this step, in the same pipeline, I'm using Python 3.6. So we see it's very, very easy. You don't have to pre-install anything or maintain different versions. Just for every step, bring the Docker image with the tool that you need. Okay, so now you understand by now that the question of what tools that Codefresh support and what versions do we support Node 10? Do we support Gradle? Do we support Python 2? All of these questions are now easy to answer because the answer is yes, because we support Docker, and every tool that either has a Docker image or can be easily packaged in a Docker image is supported. And it's pretty much every tool that you can think of. And another good thing about this concept is that the pipelines are now future-proof, because you can use any existing Docker image from either Docker Hub or any private registry, but also every new tool that comes out or every new version of an existing tool that comes out, you can immediately package it in a Docker image, or probably somebody else will do it for you and upload to Docker Hub, and then you can just use this Docker image. So it's future-proof as well. So we talked about using different tools in the same pipeline. We talked about adding additional tools to our pipeline. Now let's talk about upgrading versions and version clashes. And this is a very familiar and popular issue. So now I don't want to add a new tool, but let's say I want to upgrade the Java version on my build node. So I created a new application using Java, and it requires let's say Java 10, and the build node currently has, let's say, Java 8. So I need to open a ticket to my operator, and I tell him, okay, I want to use Java version 10. And then the operator is even in a bigger problem, because now he sees that he has Java 8 or Java 9 installed on the build node, but I'm requesting Java 10. So he has to go and see the differences between the versions. He then has to know how to install Java 10. And then he also faces the question of, should I keep the old version or should I remove it? And the same goes for every tool, or like Node.js or Python. And again, this is a real screenshot of a real platform with real tickets that you see users asking to add different versions or newer versions of tools like PHP 7.3, upgrade Maven to this version. But on the right-hand side, you can also see the other issue. For example, older versions of R are no longer available. So let's say I have a legacy application that uses an older versions of R, and now somebody else has to upgrade the version of R for his new application. Now I simply can't run my pipeline anymore because the old version of R is no longer available. So this creates a lot of issues. Now let's see how easy it is to update a version of an existing tool with container-based pipelines. So we will use actually the same pipeline as before. And if we take a look at this pipeline, we see that all I have to do to upgrade the version of Python for this step, for this application, is simply use a different version. So I can just comment out this line and add this line instead. Now I want to upgrade from Python 3.6 to Python 3.7. I can simply use the Python 3.7 Docker image, and that's it. I don't need to break anybody else's pipeline because I'm upgrading the version. I don't need to install a new version on my build node, nothing like that. I simply use a different Docker image that has the version that I want. So very, very easy to upgrade tools. You don't have to talk to the operator. You don't have to mess up a build node and then break somebody else's pipelines. Now, one of the main problem is using tools with different versions. So using the same tool, but with different version, and this is a very difficult problem until recently. And I think Python is one of the main examples. And for that, a new software industry was actually created called version managers. And version managers is an additional software that is in charge of maintaining different versions of the same tool. For example, you have RVM for Ruby, and you have a similar thing for Python or for Node. And this, so these tools can help you maintain multiple versions of the same tool, where you can just pass some parameter and say that you want to use an older version or a newer version. But this actually creates another problem, because now you also need to make sure that you update the version of the version manager itself to support newer versions of the tool that you want. And it's just like an additional software that is there to solve a problem that shouldn't have existed in the first place. And so it just like adds more maintenance and more work for you to do. And again, I mentioned Python. Python is one of the classic examples, because a lot of users are still using older versions of Python, like Python 2.7 or 2.5, but there are also newer versions that were introduced. And here on the screenshot on the left, you see an example of a real traditional VM-based platform with the different versions of Python that it supports. So it's proudly saying we are supporting versions 2.6, 2.7, all the way to 3.7. But what about 2.5? Or let's say I want to use an older version, or let's say now a newer version of Python is released. I have to wait for the platform to update and add this new version. While with Docker, you don't have to worry about this at all. You don't need version managers, because Docker, the version of Docker doesn't affect the versions of the tools that are running inside. So it doesn't matter what version of Docker you have installed. Every tool with every version already has a Docker image, or can be easily packaged in a Docker image. And again, its own version is independent from the tools. So you can have Docker 1.17, but still have Python 3.7 on it, or Python 2.5, or any version that you want. So it's not dependent on something else. And if you think about Codefresh's Python support, like what versions of Python do we support? So we support every container ever made. And on the right, you see an example from Docker Hub with all the different Docker images for every single Python version. And you see that all of these Docker images are already available, and we support obviously all of them, but we also support every Docker image that you can make in the future. So now let's say a new version of Python is released. You don't need to wait for Codefresh to update a version. You don't need to ask for your operator to install this new version on your build node. You simply go to Docker Hub, grab the Docker image with the new version, or you can even create a Docker image with the new version yourself by simply creating a Docker file. So now let's see another demo with an example of using multiple versions of the same tool. So multiple versions of Python and multiple versions of Node in the same pipeline. Okay, so again, here I see my YAML file. And now let's say that I have one Node application that is using Node 11.1. I'm packaging it here as we have seen earlier. And then on the same pipeline, I want to also use a different application, different Node application that uses Node version 9.3. No problem, they can live happily side by side. Same thing for Python, no problem with having different versions of the same tool on the same pipeline. And we can see it on the pipeline itself. So here I'm packaging my first Node application, and it's using version 11.1. Here I'm packaging my second Node application. It's using Node 9.3. Here I'm packaging my first Python application that is using Python 3.6. And at the last step, I want to deploy by communicating to AWS. And in this case, here I'm using Python 2.7. So no problem of having all of these different versions of the same tool on the same pipeline, don't need to use version managers and update and maintain the version managers themselves, no problem. Now, another interesting question and concept about CI and CD pipelines is sharing data between steps. So how to transfer data between steps. This is a classic example of that is, let's say you are running some tests on the first step, and then you want to collect the test results on the next step. Or another example is when you are using dependencies. So let's say I have a node application, I want to download all of the node modules in the first step and make sure that they exist in the next steps so that my pipeline is faster. Because as you know, it can take a lot of time to download the node modules. I don't want to download them from scratch on any step, on every step. So traditionally, this is a problem that was solved using special settings. So a VM-based CI platform forces you to use special directives in your pipeline, usually in the form of cache or artifacts. So as a developer, you need to specifically decide what folders will be moved from step to step. But especially for operators, this is a problem because you need to be an expert on everything. You need to know where the Maven cache is stored. You need to know where the Node cache is stored. You need to know where Ruby cache is stored in order to move these folders to the next steps. With Codefresh, we're doing something completely different. So because we know that we're using containers and we know that containers have volume support, behind the scenes, we completely automatically, with zero configuration required, we mount a shared volume between all of the pipeline steps. So each pipeline has its own volume. Now this volume also includes the project's directory itself. This makes all cache settings and artifact settings obsolete because you know as a developer that everything you have in your project folder and also any cache folder you have, it will be automatically available in all of the pipeline steps. And this is also a great way to cache subsequent builds for the same pipeline. So after the pipeline is completed, we can cache this volume, and when a new build is triggered, we remount the volume in the next run. So all of the folders that were there at the end of the previous run will still be there in the beginning of the next run. And this will make your builds run much, much faster. So now let's see an example with Node. And Node is one of the classic example with node dependencies. So what I will do in this example is on the first step, I want to run npm install and download the node modules. And then the next step, I want to run a unit test and I need the modules in the next step. So let's see how this will work in Codefresh. Okay, so I have this pipeline, and we can look at the YAML file for this pipeline. So let's see what I'm doing here. This pipeline simply has two steps. The first step will download the dependencies. It will use the official image of Node version 9, and it will simply run npm install. And the second step will run unit test. It will use also the official image of Node version 9. And here I'm running some commands to see my working directory and see if I already have the node modules, and then run npm test to run my unit test. So as I mentioned, I don't need to add any special configuration, any special cache settings. And I see that the second step runs the unit test, and I see that this is the working directory and the node modules folder is here automatically. I didn't have to pass it to the next step. The cooler thing is that because this is not the first time that I'm running this pipeline, even the first step doesn't download the node modules. And because the volume is persistent per pipeline, so only on the first execution of this pipeline, this step of downloading the dependencies actually downloaded the node modules. And then the next executions of the same pipeline already have the node modules on the volume. So this step will run really fast. You see, just 29 seconds. Then it will run the unit test. Again, don't need to download the modules again. And the whole pipeline finishes in less than a minute. So this is how we handle volume and passing data and sharing data between steps. By the way, we also have, and I think we're the only platform that have this for free and out of the box, caching on the intermediate layers of the Docker image. And so if you build the Docker image as part of your pipeline, we cache all of the layers, and then next time you build this image, we can pull the layers that already exist from the cache. So this was about sharing data between steps and how Codefresh handles it in a pretty unique way. Until now, we saw only how to use a pre-made Docker image. But now let's see an example of using dynamic and building dynamic Docker images as part of your workflow. So sometimes as a developer, you want to create your own custom Docker image as part of the pipeline. In this example, we create a new Docker image in the first step. We will push it to the private Docker registry that comes with your Codefresh account and use this image in the next step. You will want to do that when you're using some very special tools, or maybe if you have an extreme case when you're trying to do something in your pipeline where no Docker image exists for what you're trying to do. So in the example that we'll see here, I'm running some Node application and I want to run some integration tests. And I'm using Mocha test framework and also Protractor test framework. So I need to create a Docker image that has all of these tools pre-installed. Now let's go and see, sorry. We can go and see this, this GitHub example, okay. So let's look at this example. Okay, so what I have here is I have my Codefresh YAML. This is the declaration of the pipeline. We'll talk about it in a second. Now I have the Docker file for my Node application. Okay. But I also create another Docker file that installs all of the test frameworks that I need for my integration test. So you see it's a special Docker image that will have both Mocha and NPM and Jasmine and Protractor all installed on the same Docker image. Because I couldn't find a Docker image that already has all of these tools specifically installed on, I created a Docker file for this. And now let's see how we can build an image for this specific Docker file and in the same pipeline and then use it in the next step. So let's see how this will look like. Okay. So let's look at the YAML file. And I see that in the first step, I'm going to package my Node.js application using the Node Docker image and download the dependencies. Then in the next step, I want to dynamically create a Docker image with all of the test frameworks that I show you in order to be able to run the integration test on the last step. So to build this Docker image, Codefresh created a predefined step called build. So you can simply set the step type as build. Point to the Docker file within your Git repository. So I'm going to the working directory inside the Git repository that we've seen. And this time I'm using the dockerfile.testing, which will build my Docker image. This will be the name of my Docker image. And then I will have a Docker image that has both Mocha and Protractor and NPM installed on. And then check out what I'm doing on the last step to run my test. This time, when I need to choose the Docker image that I want to run these tests in the context of, I simply point to a variable, which is the name of my previous step. So because we have a private Docker registry that every image that you build as part of the pipeline is automatically pushed to this registry, we can then automatically pull this image in the same pipeline and then run my test. So I'm running Mocha version and portability version to see that I actually have all of these tools here in this step. And let's look at the build of this step. Okay, so I see that here I'm packaging my node application. It was successful, this step was successful. Then I'm building my image specifically for the test that installs Mocha and Protractor. And then I can run my unit test at the last step, and I can see that I have the versions for all of the tools that I needed. So this is an example again to create a dynamic image as part of a pipeline and then use it in the same pipeline. Now let's talk a little bit about Codefresh plugins. And if we think about plugins for other traditional CI/CD platform, let's say take Jenkins, for example. So it's not that easy to create and use new plugins. Why? Because first of all, they have to be specific to the platform. So there is some kind of vendor locking. And so for Jenkins, you develop plugins that are specifically for Jenkins. You have to use the programming language that is tied to this tool. In Jenkins' case, it's Groovy. You also need to learn the API for this tool to create a plugin. And also, then you need to test and install this plugin. That can also be challenging. With Codefresh, a plugin simply equals a Docker image. Because every step in the pipeline is a Docker image, you can think of plugins as Docker image. And what's good about that is, first of all, it's not tied to any programming language. You can simply take a Docker file and build a Docker image. You don't have to use a specific language like Groovy. It only requires Docker knowledge, which is generic. It doesn't have any vendor lock-in. It's then easy to test. It's easy to store and to search. And we already have a lot of plugins that we created. So if you go to steps.codefresh.io, you'll see a library of free plugins that we created for you. So you can see there are simple plugins like copy to S3, where then you don't need to run any, and it's created as self-contained functions in the sense that you don't need to run any AWS commands. It's simply a Docker image where you pass some environment variables, like what is the source that you want to copy and what is the target of your bucket, and it will copy it for you. For example, more advanced deployment methodologies like blue-green deployment, we create a specific Docker image that is called Kubernetes blue-green, and it's again created as a self-contained function. You don't have to run any kubectl commands. You just provide some environment variables with the service that you want to deploy to, the name of your deployment, the new version, the namespace, and the name of your Kubernetes cluster. And the image behind the scenes will run the kubectl commands to perform the blue-green deployment. By the way, we also create a workshop to build your own Codefresh plugins. And again, this is pretty straightforward. If you have just basic Docker knowledge, you can go and then contribute your own plugins. And we have a lot of users that already did that and contributed it to the community. And if you think about it, because these are simply Docker images, you can use them anywhere. You don't even have to have a Codefresh account to use them. You don't have to use them in Codefresh. It's just generic Docker images. So now to summarize, we saw a new approach of having container-based pipelines with Docker images as build step. We saw how easy it is to upgrade tools. Just bring a new image with the version that you want. We saw that it solves the problem of maintaining multiple versions of the same tool. Don't need the versions managers anymore. You can use different versions of the same tool in different steps of the pipeline by simply providing the image with the version that you want in every step. We saw how you can dynamically create and build images and then use them in the same pipeline. And we understood the concept of Codefresh plugins that are simply Docker images. So thank you very much. Now let's see. If you have any questions, feel free to post them on the Q&A box. And I currently don't see any questions, but we do have a few more minutes. So again, feel free, just post your questions in the Q&A or even in the chat, and we can answer them now. Okay. So I see there's a question about comparison between Codefresh and Drone.io. I think that we created a blog post for that. So let me see. Yeah, so there's a detailed comparison. We also have an article here in our knowledge base of how to easily convert from Drone.io to Codefresh. So you can go and check it out after this after the webinar. I'll check if we have a more in-depth comparison. I can share it with you, but if you just Google it, see there's one comparison that was made here. So some things that you can think about is that Codefresh has both API and CLI support for all actions in the platform, so you don't have to use the UI. It provides a free private Docker registry and also a free private Helm repository that you can use, and it has a native support for Kubernetes deployments. And so you can go and check it out. If there are any other questions, again, feel free to post them. Okay, so I see that there's no further questions. Again, if you do start playing with the platform, you know, you can go and sign up for free. You get 120 builds per month completely for free. So you can even take the examples in the GitHub repository and then start building your pipelines, see how much you can improve the speed and ease of use and maintenance. And if you have any questions, feel free to drop me an email here at guy.salton@codefresh. So thank you very much for joining.